Suppose I've got a function, it's 1 to 1. And then g is going to be an inverse of this function if the following is true. F of g of x is equal to x for all x in the domain of g. And I also need this as well. Both of these have to be true. G of f of x equals x for all x in the domain of f. Okay? Both of those things are true. Life is good. So I'm going to look at two different examples. First example, everything's going to be nice. Second example, something's going to break down. Okay? And we'll talk about maybe, if you're lucky, how to deal with that. Okay? All right. Let's do the first example. I want to know, is this function, does this function have an inverse? So the question is given that function, find the inverse. Before we find the inverse, we need to know whether or not it exists. So the first thing is this function 1 to 1? So let's see. Now, I'm going to set Brenda of A equal to Brenda of B. The question is, does this imply that A equals B? Now, you may be asking, why do I use this part of the definition of 1 to 1 versus the other? And the reason is, I tried them both, and this one came out to be nicer. Okay? So there's no easy way to say which one do you use at a given time. You just try to work with what you have and go from there. So in this case, I looked at this. And I'm going to basically substitute this definition for Brenda in. I'm going to do the algebra to see if that has to necessarily be true. The nice thing about algebra is that most steps, as you go from one to the other, go backwards. Okay? Sometimes that breaks down. We'll talk about that. So let's see. So Brenda of A says take 3, and for any number, what Brenda says is take 3 over that number minus 1. So that means Brenda of B is equal to that. So let me see, let me do this. Let me divide both sides by 3. So I do that to the left, I've got to do that to the right. So now these 3's cancel. Okay, now I've got to be careful here. A can't be 1, B can't be 1. Okay, otherwise that's not in the domain of this function. Let me multiply both sides by a minus 1. And if I multiply one side by that, I got to do both. Now here, these are going to cancel. So I get that. Now I've got, this is causing a problem, so let me multiply both sides by b minus 1. Now those will cancel. So I get that. And now let me add 1 to both sides. To get rid of that, and I get that B has to equal A. And notice all the steps I have here work backwards, so if Brenda of A equals Brenda of B, then A must be equal to B. So the function is 1 to 1. Okay? Now that means I've got a license to kill, and I can go out and try to find its inverse. Now that's the second step. Okay? So I've determined that this function is 1 to 1. I can now go through and figure out where it is. Right? There's no point in looking for something that's not there. So here's what I'm going to do is I'm going to set y equal to this. And the question is, if you give me the value of y, what's the value of x? So it's the same thing as basically just solving this equation for x. So what am I going to do? I'm going to multiply both sides by x minus 1. Okay, that'll cancel those. that. Now again, I'm assuming I know this value for y. I know what that is. So I want to get that over on the opposite side away from the x. I'm going to divide both sides by y. If I do that, those things will cancel. And now I want to get x by itself, so I'm going to add 1 to both sides. So the 1 minus 1 cancels, goes to 0. So I get this. So now let me call this inverse h. H of y then is 3 over y plus 1. Okay. All right, let's check our work and see if this really is the inverse. And we're going to do that by composing these two functions and see if I get the identity out of this. So let's see. What is Brenda of h of y? Okay, so to figure out what Brenda does to h, I got to figure out what h does to y. So we work from the inside out. What does h say? H says you give me a number, I take 3 over that number and add 1. Now what does Brenda say? Brenda says, you give me a number, I'm going to take 3 over that number, and then subtract 1. And now we're just going to play algebra games. Let's see, the easiest thing here to do is cancel that. I have that. This is kind of a mess. So let's do this. I don't like fractions in the denominator. So let me multiply the top and the bottom both by y. If I do that, those will cancel, and what am I left with? 3y over 3. Getting excited. And now 3 divided by 3 is 1, so that works out. Let's go the other way. Oops, now Brenda is a function of x. So I get this. What is h? No, I don't know what h is going to do here because I don't know what I'm going to feed it. But I do know what Brenda's going to do to this thing. Brenda says, well, you give me a number, I take 3 over that number minus 1. And what does h say? H says, you give me a number, in this case this whole mess, I take 3 divided by that number, and then I add 1. Okay. Oh, what a mess. Okay, so what can I do? Again, I don't like fractions in the denominator. Let me break this out and be a little nicer. Let me rewrite this. So to get that out of the denominator, I'm going to multiply the top and bottom by this denominator. So those things will cancel. So what do I do now? I've got now 3 times x minus 1 divided by 3 plus 1. 3 divided by 3 is 1. X minus 1 plus 1 is x. So it gives me the identity. Okay? So that's nice. Works out well. Okay. All right. Now I'm going to leave it up to you to notice something. So this should be a nice homework problem. Notice whatever comes out of h has to go into Brenda. So in terms of the range and domain of this function and the range and domain of this function, they've got to somehow match up. So whatever comes out of here needs to go into the domain here. So this has to match up with that, and vice versa, this has to match up with that when we reverse that, okay? So I will leave that as a homework question to find the domain and range of Brenda and then the domain and range of this function h, and see how they match up, okay? All right. Now, let's look at another example. We have a new function, we'll call it Bart, what do we have with BART? BART is that function. I want to find the inverse of that, if it exists. So the first thing I need to do is ask, is it 1 to 1? Okay, so let's do this. I'm going to do the same thing I did before. I'm going to set those two things equal and see if that implies that A has to equal B. And again, the reason I know to use this definition of 1 to 1 is because I worked it out in advance, and I already know it's going to work. So what does BART of A say? BART says, give me a number, I take the square root of that number minus 1. So that has to be true. Let's see. So let's see, the thing on that's causing me the problems here, I can't get into anything in here because there's a square root on the outside. So I'm going to square both sides. If I do that, I get A minus 1 equals B minus 1. I can add 1 to both sides. And that means A equals B. So this function is 1 to 1. In fact, if I graph it, so this is going to be at 1. I can plug in x equals 1 as in the domain, but anything smaller than that is not. I get something like that. Okay. So what do I have? I have here that the domain is greater than x greater than or equal to 1, and the range is y greater than or equal to 0. Okay? All right. Let's see if we can find the inverse. So it's now we know it's 1 to 1. We can find the inverse. So let me just set this equal to that. Okay, so now I'm going to solve that for x. So I'm going to square both sides. And after x, I want to solve this in terms of x. So I add 1 to both sides. This should be a 2. So I get that. Okay. All right. Is this going to work? What does this function look like? So if I define a function, we'll call it h of x, this is going to take 1 plus x squared. I'm claiming this is the inverse. So everything should work out fine, right? Let's test to see if it's the inverse. Okay. So let's take h of BART, see what happens. What does BART do? BART says take the square root of x minus 1. H says take whatever you give me, add 1 plus the thing squared. So this thing squared is going to be x minus 1, so I get 1 plus x minus 1. I get the x, and life is good, no problems. Okay, so let's turn it around. So this is my BART of h of x. So what does BART do to h? H says what? Take whatever you give me, take 1 plus x squared. And then BART says take the square root of whatever you give me, minus 1. 1 plus x squared minus 1. And now I have a problem in that the square root of x squared, well, think about this. If I plug in x equals minus 2, I get the square root of 4 is going to be equal to 2. I plug in, oops, x equals 2, I get the square root of 2 squared, which is 2. So this is really just a fancy way of saying the absolute value of x. So this is not the inverse. Okay, there's a problem here in that this BART of h of x does not necessarily just return x, it returns the absolute value of x because you're squaring something which gives you a positive number. Then when you take the square root, as defined here, it's going to give you another positive number. What happened?